Hello friends, welcome to Study Spectrum in Rohit Sarki class. Today we are going to discuss about the CBSE Board Standard 9 subject Science Chapter 2 Is Matter Around Us Pure? Friends, what do we mean by pure exactly? If we go to the market to bring a milk or maybe a curd, a ghee, we always say that we want a pure milk, we want a pure ghee. Even on the packing of those products, if you see, there is a written pure. We always roam around in the cities in rush time and we say, air is not pure nowadays. It's so much polluted here. If we want to have a pure air, we need to get up early in the morning, or else on the weekends, let's go somewhere out in the countryside to get some pure air. So, in our day-to-day life, when we say things are not pure, what do we mean by that exactly? Actually, this is a regular life language. But when it comes to a scientist, we are all budding scientists, right? According to the scientist, even purest of the milk is not pure. Purest of the air in the early morning time, or maybe air at the countryside where there is no pollution at all, even that air is not pure. When it comes to a science, pure thing means it consists of all of its constituents, elements, or all the particles which that thing is made up of. Those particles are of the same chemical nature. That thing cannot be subdivided or separated into its constituents, different constituents which have different chemical properties. Such things which cannot be separated into its constituents by any physical process is called as pure thing. What we are talking about? Let's say a simple example. When we say air is not pure nowadays, what do we mean by that? We mean nowadays there is so much pollution, there is so much increase in uses of vehicles which actually emit lot of CO2. There is so much industrialization nowadays, and through chimneys of those industries there is a black smoke coming out which gets mixed with the air, and there is so much pollution. So the air which doesn't have any kind of adulteration, no extra CO2, no industrial emissions into it, that is the pure air. But actually, air consists of many gases. We all know that by this time, right? Major constituents of the air is nitrogen, which consists of around 78-79%, oxygen, CO2, and many other gases in small portions. So, this air is a mixture of all these gases. So, according to a science, according to all budding scientists, always remember, even the purest air which we call is not pure. It's a mixture of other pure gases. So, today we are going to think about all such kind of mixtures. Actually, in our day-to-day life, we always look at the things as an entity. For example, milk. If a milkman brings a milk in the morning at home, if he brings it with adulteration of the water, we call milk is not pure nowadays. But if some milkman brings without adulteration, without adding any water into that milk, we will say milk is pure. But when we are discussing about the scientific facts, we need not to look at the thing as a whole entity, but we need to think at the molecular level, atomic level, a particle level of that substance. So even the milk is not a pure substance, it's a mixture of water, fat, proteins, because whatever constituents I'm talking about in the milk, those have different chemical natures, and the mixture of all those makes the milk. So in short, while discussing about the scientific aspect of anything, any substance, we are going to look at atomic, molecular level, a particle level, and we are going to talk about their physical and chemical properties. So, is matter around us really pure? Very less quantity, very less things, very few things around us are actually in the pure form scientifically. Most of the things around us is actually a mixture of other pure substances. What is this mixture actually? Let's look at it. Any substance which constitute of all the particles which are of the same chemical nature is called as a pure substance, and a mixture of two or more such pure substances which can be separated with the physical processes is called as a mixture. For example, if we take some salt, a pinch of salt, and we mix it with a glass of water, we stir it properly, you know where that salt has gone. It has vanished. We are not looking at the salt particles anymore. Actually, that salt has been dissolved in the water. We cannot see its dissolved particles. But now we can say that a glass of water with dissolved salt into it is a mixture of water and salt, sodium chloride. Now, there is a physical process called as evaporation. What happens when all the water from the glass has been evaporated? You know, the things left back are the salt crystals. Now, salt itself is a pure substance. Water itself is a pure substance. Mixture of these two, in which via physical process we can separate it again, is called as a mixture. Salt cannot be further separated into its chemical constituents, that is sodium and chloride. We cannot separate these two constituents with the help of any physical process. So, salt is a pure substance, it's not the mixture. Water, we all know that water is consistent of, it is made up of hydrogen and oxygen, H2O. Two atoms of hydrogen and one atom of oxygen combines to make the molecule of water. Now, can we separate hydrogen and oxygen from the water with the help of any physical process? No. That means water is a pure substance. Salt is a pure substance. Mixture of such two pure substances is called as a mixture. There are two types of the mixtures. One is homogeneous mixture and heterogeneous mixture. What do we mean by homogeneous mixture? The same example, salt added up in the water, stirred well. The dissolved salt in the water is actually a homogeneous mixture. Why? Because it tastes same throughout. The distribution of the salt particles, dissolved salt particles in that water is uniform throughout. So, when the distribution of the particles is same throughout of two substances in the mixture is called as a homogeneous mixture. But let's take that same salt and take some crystal of the sugar, let's mix it. What do we get? We get a heterogeneous mixture. Why? Because we all know that the distribution of the salt and sugar particle into each other is not uniform. So the homogeneous mixture and heterogeneous mixture are the two types of any mixture. So there are two types of this mixture, homogeneous and heterogeneous. Uniform distribution of the particles in the mixture makes a homogeneous mixture, and non-uniform distribution of the particles in the mixture makes heterogeneous mixture. We have already seen the examples. Dissolved salt in the water or dissolved sugar in the water is a homogeneous mixture, or whatever air is there in our atmosphere, that is a homogeneous mixture, because the distribution of oxygen, nitrogen, carbon dioxide, other gases, the distribution of such different constituent particles is uniform throughout wherever we go, provided that air is not polluted. But what about mixture of salt and sugar, or what about the soil? Is soil a homogeneous mixture? No, soil is made up of many pure substances mixed together, but the compositions is not throughout. At the different geographical areas, constituent particles distribution in the soil is different. So soil can be a heterogeneous mixture. Now, while discussing about the mixtures, we are going to see what are the solutions, suspensions and colloidal solutions. Let's take an example, a salt dissolved in a water. Let's take a chalk powder as well. Let's take a glass of water, another glass of water, mix that chalk powder into that, stir well, and just now see, two of the mixtures, do they look same? In first glass of water, salt has been dissolved. Now we cannot see salt particles with our naked eyes, right? But when it's a chalk powder stirred well in a glass of water, we can still see particles of chalk floating in the water. So in the first glass of water we get solution. In second glass of water we get suspension. Now think about the smoke in the automobile exhaust. There are the black carbon particles in the gaseous state mixed in the air. What is that? There are such n number of examples of different kind of mixtures. We are going to see their properties, how do they behave, what are the stable mixtures, what are not. Let's start with the solution. So let's start with solution. What is a solution? A homogeneous mixture of two or the more substances is called as a solution. This solution has got two parts. The one part is a solute and another part is a solvent. When we are talking about the solution, there is a mixture of two or more substances, right? Let's consider an example of two pure substances having a homogeneous mixture, which we are calling as a solution. One of them is definitely in lesser quantity, so that automatically becomes solute, and one is actually in a very large quantity, which actually dissolves all the solute in itself. That is called as a solvent. Let's take an example of iodine tincture. What is an iodine tincture actually? It's a mixture, right? Iodine crystals dissolved in an alcohol is called as iodine tincture. In that, which of these two is in lesser quantity? Iodine. So iodine becomes a solute and alcohol becomes a solvent. Salt dissolved in water. Salt is a solute. Water is a solvent. So, solute and solvent makes a homogeneous mixture which is called as a solution. Let's see what are the properties of the solution. Very first, it's a homogeneous mixture. Distribution of the solute particle in the solvent is uniform. And most importantly, solute get dissolved in solvent. So, particles of the solute in dissolved state we cannot see with our naked eyes. What may be the particle size in the solution? The particle size are so smaller. It's even smaller than 1 nanometer. 1 nanometer is 10 raised to minus 9 meter. So the particle size is so smaller that we cannot see it with the naked eyes. That is the another reason why these particles cannot disperse the light. Let's take an example of any solution, a salt dissolved in a water. Let's take a glass of water, dissolve some salt into it and throw a light beam on it with a torch. Look from the front side. Can we see the path of light? No. Why? Because when light is passing through the solution, particles of the solute are so smaller that they cannot disperse the path of light. They cannot deviate the path of light. So, in this solution, path of light is not seen because particle size is so small, even smaller than 1 nanometer. Now, if we take that solution, a pinch of salt dissolved in a glass of water, and if we leave it undisturbed for some time, what do you see? Does salt particles settle down at the bottom of the glass? No, not at all. That means solution is a stable mixture. Even it is left undisturbed for some time, it doesn't change its form. There is no change seen. So solution is a stable mixture. And the last important property, if we take a filter paper and if we filter a glass of water in which salt is dissolved, what will you get? Can you separate a salt from that water? No, not at all.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. Make sure your mustache hasn't started coming. Choose the right study time and forget games, IPL, IHL, rock and metal, guitar, X. The right group and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger. The night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
So these are the properties of solution. With the help of these properties, we can identify which is the solution. Tell me, is the seawater a solution? Yes. Is the river water is a solution? Yes. Is it a fog, a mist is a solution? No. Why? Because there is no uniform distribution of the particles. When we are talking about a fog, a mist, they are the water droplets dispersed in the air. And the particles are seen with the eyes, right? We cannot see through the fog because particles are seen through the eyes. But what is the solution? Solution is first a homogeneous mixture. Particle size is lesser than 1 nanometer, so those are not seen by naked eyes, and they cannot disperse the pathway of the light passing through the solution, so pathway is not seen. And if we left that solution undisturbed for quite some time, particles do not settle down at the bottom, and these particles cannot be separated with the physical process of filtration. Now let's talk about the concentration of the solution. What is the concentration of the solution? What this phenomenon is? In simple terms, concentration of solution is a quantity of a solute in given quantity of a solvent. Let's have an example. If we take some 100 ml of the water and 10 gram of the salt, mix it, stir it well. Salt crystals are dissolved now, they are vanished. We cannot see with the naked eyes, right? Take another 10 gram of salt, put it in the water, stir it well. What happens? It also gets dissolved. Okay. Take another 20 gram of salt, put it, stir it well. What we get? Some of the crystals get dissolved, some of the crystals are still struggling getting dissolved. The dissolution time has increased. We have to put more and more efforts for that salt to get dissolved. Put another 50 gram of the salt. Does it get dissolved into it? No, it's not dissolved. That means there is a limit how much solute can get dissolved in that given quantity of the solvent. Now, same 100 ml water with some quantity of the salt undissolved in it, put it on the flame. Increase the temperature of the solvent, of the water. Now what you get? That remaining salt has been dissolved now. Put another 10 gram of the salt and see what happens. That also gets dissolved. That means there is an amount of the solute in given temperature, in given amount of this solvent, which can be dissolved. and there is a limit to it. When at a given point of temperature, no extra amount of the solute can be dissolved in that solvent, that mixture is called as a saturated solution. There is a saturation point of each solute and solvent for given temperature, and that amount, how much amount of that solute can be dissolved in given amount of the solvent, that is called as a solubility of that solute in given solvent. Now you can understand that solubility of a solute can be different for the same solvent, for the same quantity of the solvent at different temperatures. Because at the lower temperature, solvent gets saturated very early, but as temperature rises, saturation is achieved even later. More and the more solute get soluble in that solvent. Now let's consider the same solvent, same quantity. Let's say a water, 100 ml of the water at the given temperature, let's say a temperature of 30 degrees Celsius. 100 ml of water at 30 degrees Celsius, how much salt can be dissolved? Maybe 20 gram, maybe 30 gram. Do the experiment and see how many grams of salt can be dissolved in 100 ml of water at 30 degrees Celsius. That makes a solubility of the salt in 100 ml of water at 30 degrees Celsius. Now take another beaker with the 100 ml of water at 30 degrees Celsius and start dissolving sugar. How much sugar gets dissolved? You can note the change because the quantity of the salt and quantity of the sugar which can be dissolved in 100 ml of water at 30 degrees Celsius, quantities differ from each other. That 100 ml of the water at 30 degrees Celsius becomes saturated with the salt. That quantity of the salt is different than quantity of the sugar that takes to make a saturated solution of 100 ml water at the 30 degrees Celsius. That means in a given temperature, same solvent has different solubilities for different solutes, and for the same solute, the same solvent has got different solubility at different temperatures. So how to calculate the concentration? Generally, there are two types to calculate the concentration of any given solution. It is amount of solute divided by amount of solvent. Amount of the solute in given amount of solvent gives the concentration of that solution, or amount of the solute in given amount of solution, not the solvent but solution, gives also a concentration of the solution. For different purposes, there are n number of ways to calculate the concentration of the solution. But for today's discussion, we are going to consider only two ways to calculate the concentration. One type is mass to mass concentration and another type is mass to volume concentration. For example, we are going to talk about amount of the solute in amount of the solution, that kind of the concentration. Let's consider a 20 gram of salt is dissolved in 100 ml of the water. How do we calculate concentration of the solution? The first type, mass to mass. Let's wait and let's consider that 100 ml of water weighs 100 gram. Now we have mass of the solute, that is 20 gram, and mass of the solvent, that is 100 gram. Let's consider how we calculate mass of solution? We all know that mass of solution is mass of solute plus mass of solvent. So 20 gram of salt plus 100 gram of water makes 120 gram. 120 gram is a mass of solution. Now we are going to calculate mass to mass calculation, mass to mass concentration. So how do we calculate? We calculate mass of the solute divided by mass of the solution multiplied by 100. That gives the percentage of concentration of the solution. Calculate it, 20 upon 120 multiplied by 100. How much it is? You can calculate it and get the concentration of the solution. Also, we can calculate it by mass to volume concentration. How? 100 ml of water, when it dissolves 20 gram of salt, how much is the volume of that solution? It remains 100 ml only. It is not increased because those 20 gram of salt crystals are dissolved, and the dissolved particles of salt occupy the spaces in between the particles of the water. So this was all about the solution. Let's talk about what are the suspension and how suspension differs from the solution. Suspension is also a mixture of two or more substances. Let's have a simple example. A chalk powder mixed with a glass of water. If we stir it well, do chalk particles get dissolved in the water? No. We can see these chalk particles with naked eyes. They are suspended in the water, right? So, suspension is a heterogeneous mixture in which the solute particles do not dissolve in the solvent, but they are dispersed, they remain suspended throughout the medium. That is called as a suspension. What are the properties of the suspension? Let's go through the properties. Very first, suspension is a heterogeneous mixture. So, a heterogeneous mixture of two or more substances in which the particles of the solute doesn't dissolve in the medium, but they remain suspended throughout the medium is called as a suspension. But this distribution of the particles must not be uniform throughout. That's why it doesn't make the homogeneous mixture. Actually, suspension is a heterogeneous mixture because distribution of the suspended particles is not uniform throughout the medium. What about the particle size? Particle size is big enough in the suspension where we can see those particles with our naked eyes. We have already taken the example of chalk powder in the glass of water. We can see those chalk particles suspended in the water, right? Now, due to the particle size, it is big enough to see with the naked eyes. It also scatters the light passing through the suspension. If we take that glass of water with suspended chalk particles and throw a beam of light through it with the help of torch, look from the front side what we see. Actually, we can see a path of light. How light is traveling through that suspension is visible, clearly visible. So, the particle size in the suspension is big enough so that we can see the particles with our naked eyes. Due to this particle size, these particles, suspended particles, scatter the light passing through them. And that is why we can see the path of the light passing through suspension. That path of light is clearly visible. Now, let's leave that suspension for quite some time undisturbed. After some time, what we get? We can see the particles are settled down at the bottom of the suspension. That means suspension is not a stable mixture. Actually, suspension is always unstable mixture because particles do not remain suspended for prolonged time if that suspension is left undisturbed. Now, this chalk powder suspended in a glass of water, just pour it through filtration paper. What do we get? Yes, all the particles of the chalk are separated on the filter paper. Why? Because those are big enough in the size, those are not dissolved in the water. So when we are talking about the suspension is unstable mixture and the particles, suspended particles can be easily separated with the help of basic physical process of the filtration. There is another very good example of suspension. Have you ever taken that cough syrup or any other syrup on the bottle of which there is a written shake well before use? Before taking that medicine, we have to shake it well. Otherwise, what happens is the medicine particles are always settled at the bottom of the bottle. That is another example of the suspension. Let's go to the next topic, that is colloidal mixtures. Now, we have already seen solution, we have already seen suspension. Now, what is this colloidal solutions? Milk is a very good example of a colloidal solution, in which actually the mixture of two substances in which the particles of one substance is dispersed through another medium is called as a colloidal solution. For example, milk. Fat particles, protein particles are well dispersed in the water, and that makes a colloidal solution called as a milk. In this, particles are uniformly spread throughout the medium, and particles are relatively smaller in size than in suspension. The particle size in the suspension is way bigger that they can be seen with the naked eyes. But in colloidal solution, particle size is relatively smaller and they are uniformly spread throughout the mixture. So it seems like it is a homogeneous mixture. But no, colloidal solution is not homogeneous. Colloidal mixture rather, is a heterogeneous mixture. But it's quite stable. If we leave colloidal solution for some time left undisturbed, dispersed particles do not settle down at the bottom. Now, what about the light passing through colloidal solution? Yes, particles are relatively smaller, but still they are big enough to scatter the light passing through them. Even we can see this when we are going through dense forest and light comes through, or maybe in a single dark room when light enters with a small hole, we can see the path of the light that is clearly visible. Why? Because there are the dust particles, there are the smoke particles suspended in the air, dispersed in the air, or maybe droplets, water particles, as in case of mist or fog. Those are dispersed in the air uniformly, and due to which when light passes through it, those particles scatter that light. So we can see the pathway of the light very clearly. Actually, this phenomenon is called as a Tyndall effect. It is named after the scientist Tyndall, which actually discovered this effect, and it shown that this effect is due to the particle size for the first time. So this is called as the Tyndall effect. We can see the Tyndall effect in suspension. We can see the Tyndall effect in colloidal solutions as well. We cannot see this Tyndall effect in the solution. That is the difference between these mixtures. Now, when we have talking about the solution, we know that the lesser quantity substance is called as the solute, and the larger quantity substance which actually dissolves that solute in itself is called as a solvent. Similarly, in colloidal solutions also, the particles of a particle of the substance which are dispersed throughout is called as a dispersed phase, and a medium in which those particles are dispersed is called as a dispersion medium. So colloidal solution is made of these two parts. One is dispersed phase and another is dispersion medium.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. Make sure your mustache hasn't started coming. Choose the right study time and forget games, IPL, IHL, rock and metal, guitar, axe. The right group and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger. The night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
So let's see what are the properties of these colloidal solutions. Actually, colloidal solution is a heterogeneous mixture. Particle size is relatively smaller, but it's big enough to scatter the light. So Tyndall effect is seen in the colloidal solution. What is this Tyndall effect? Due to the particle size of any mixture, let it be in a suspension or in a colloidal solution, when light is passing through it, particle size is big enough to scatter that light, and due to this light is scattered, the pathway of the light is visible. It doesn't happen in the solution. It happens only in the suspension and colloidal solutions. So this Tyndall effect is seen in colloidal solution as well as suspension. This effect is named after the scientist Tyndall, which actually observed, discovered and narrated this effect for the first time. Now, if we leave this colloidal solution for quite some time undisturbed, do the dispersed phase settles down at the bottom? No, not at all. So, this colloidal solution is quite stable mixture. Particles dispersed phase doesn't settle down at the bottom as in case of suspension. Also, we cannot separate the dispersed phase from dispersion media just with the help of physical process of filtration. In suspension, we could do it because it was quite unstable mixture with the big particle size. But in colloidal solution, we cannot separate. In the solution, we have already seen that there are two parts which makes that solution. One is a solute which actually gets dissolved, and another is a solvent which provides the medium for the solubility of the solute. Same thing in colloidal solutions also. There is a dispersed phase and a dispersion medium. A lesser quantity substance, particles of which actually get dispersed throughout, makes the dispersed phase, and a medium which actually provides the particles of dispersed phase for its dispersion, that is called as the dispersion medium. Now, according to dispersed phase and dispersion medium, there are different type of colloidal solutions. We'll go through them. What are the different types of colloidal solutions? Very first, if liquid serves as a dispersed phase in gas as a dispersion medium, what do we call it? It makes a quite good colloidal solution. We call it as a aerosol. What are the examples of aerosol? Fog, mist. We all know that small water droplets, water particles are actually dispersed in the air in early morning in the winter days, right? We have seen the fog. That fog also shows the Tyndall effect. When we are driving in the fog, we start the headlamp of our cars, we can see the pathway of the light passing through the mist, the fog. Why? Because fog is a colloidal solution in which water, liquid, is a dispersed phase, dispersed in air, the gaseous dispersion medium. Now, let's think about the solid as dispersed phase in a gas as a dispersion medium, that we will also call as a aerosol. Example of it is a smoke or maybe an automobile exhaust, in which there are the black carbon or exhaust particles. Those are the solid particles but dispersed in the air. Due to this smoke only, we can see the pathway of the light when light enters a dark room from a very small portion, a very small hole. We can see the pathway of light. That is the Tyndall effect. Why? Because there are the smoke particles, there are the dust particles present in the air. Those are dispersed throughout the air. So there is a Tyndall effect. Now let's move ahead and let's think about the gas as a dispersed phase, dispersed in a liquid as a dispersion medium. What do we call it? We call that colloidal solution as a foam. A shaving cream which makes a good lather, good foam, that is a very good example of this colloidal solution where actually the gas is dispersed throughout in the liquid. There are the small gas bubbles, air bubbles in the liquid, right? Let's see next colloidal solution in which liquid itself provides as a dispersed phase into liquid only. Liquid as a dispersion medium and liquid as a dispersed phase, that colloidal solution is called as an emulsion. What is the example of emulsion? It is a substance we use in our day-to-day life. Milk. Milk is a very good example of an emulsion. It's a colloidal solution. All the proteins, fats in the liquid form are dispersed in a liquid, that is water, that makes the milk. Now think about the solid dispersed phase, dispersed in a liquid. A solid dispersed phase in a liquid dispersion media is called as a sol. What is the example of sol? Mud. After the first rain, there is a mud here and there. Actually, the soil particles, the solid particles are dispersed in the water that makes the mud. Mud is a colloidal solution. Now let's move ahead and think about solid as a dispersion medium. If gas is dispersed, gas serves as a dispersed phase in any solid dispersion media. What do we call it? That is another colloidal solution and we call it as a foam. A rubber, a sponge are the examples of this colloidal solution, that is foam. Let's think about the liquid. Liquid as a dispersed phase, dispersed in any solid dispersion medium, that is called as a gel. Gel is a colloidal solution in which liquid is a dispersed phase in a solid dispersion medium. Any jelly, butter, these are the example of gel, a colloidal solution. And now, if a solid dispersed phase is dispersed throughout in a solid dispersion medium, what do we call it as? We call it a solid sol. What are the examples of that? A colored gemstone. Colored gemstone, or maybe a milky glass. These are the examples of solid sol, a colloidal solution. So this was all about the colloidal solutions. In today's discussion, we have seen what exactly the pure substance is. What is the purity in scientific terms? Actually, whichever the substance we look around, most of them are not pure on the atomic or molecular level, or we can say at the particle level. Those are the mixtures. Mixtures are of two types, homogeneous mixture and heterogeneous mixtures. We have already seen the properties of solution, suspension and colloidal solutions. So we have already seen the properties of solution, suspension and colloidal solutions. We will talk about the separation of its ingredients in our further discussion. Thank you.